We are in Rosen, Discrete Mathematics and its Applications, section 1.8 on proof techniques and strategies. And this is a short video to run through kind of a non-typical math proof, but still a proof nonetheless, using tilings to say certain things that are true and false about tiling checkerboards. So first example is, can we tile the standard checkerboard using dominoes? Well, turns out yes, because we will exhibit a constructive existence proof. Remember, a standard checkerboard is 8 by 8 squares with alternating colors, and a domino will cover 2 squares at a time and can be oriented either vertically or horizontally. And then the constructive existence proof would be to take those, in this case, we're going to use horizontally oriented dominoes and demonstrate that we can tile the 8 by 8 checkerboard with 4 columns of 8 dominoes, sideways oriented dominoes. Okay, there's other solutions as well, but we only need to exhibit one to prove that we can do this. Let's look at another example. All right, can we tile the checkerboard if we remove one of the 4 corners? Can we tile it with dominoes? Well, our checkerboard has 8 times 8 equals 64 minus 1 square, so 63 squares. And since each domino has to cover 2 squares, we have to have an even number of squares in order to do the tiling. So 63 is not even. We have a contradiction. And we cannot tile a checkerboard with a 1 square removed using dominoes. All right, let's look at another example. Our last example will be, okay, so what if we remove 2 squares? Can we tile a board obtained by removing opposite corner squares from the checkerboard? Here's a checkerboard with the upper left and the lower right square removed. And can we tile that using either some combination of vertically or horizontally placed dominoes? And you could start to try a constructive solution. Go cover these 2, then these 2, and then I'll have to go like this, and that means I'll have to go like this. And so you'd have to try to fill out a number of different ways to come up with a tiling. Let's think about it in another way. All right, so we know that there are 64 minus 2 equals 62 squares on the board. And since we're using dominoes that cover 2 squares, we'll need 31 dominoes. But here's something to keep in mind. Because of the way we color the checkers on the checkerboard, each domino has to cover 1 black and 1 white square. That means we would have to cover 31 black squares and 31 white squares if a tiling existed. But if we remove opposite corner tiles, they have the same color. So that means we either have 30 black squares and 32 white squares, or 32 black squares and 30 white squares. And so we have a contradiction, and we cannot tile a checkerboard with dominoes where we've removed opposite corner squares.